Hey there, science fans. We're diving into the world of chlorine today. You know, that stuff that keeps swimming pools clean, but guess what? Chlorine is way more than just a pool cleaner. It's a fascinating element with a whole bunch of cool uses. We find chlorine in our everyday lives, not just at the swimming pool. It helps make our drinking water safe, keeps our hospitals clean, and even helps make our clothes brighter. Chlorine is one busy element. So get ready to explore the amazing world of chlorine, from its place on the periodic table to its role in modern science. Let's go!
First things first, let's find chlorine on the periodic table. It hangs out with the cool kids in Group 17, also known as the halogens. Chlorine is a bit of a loner. It's rarely found by itself in nature. It prefers to pair up with other elements to form compounds. One of its favorite partners is sodium. Together they make sodium chloride, which is just plain old table salt. Chlorine has a yellowish-green color and a strong, pungent odor. Think of the smell of bleach, and you've got the right idea. And just like bleach, chlorine is a powerful oxidizing agent. That means it can steal electrons from other elements, making it great at breaking down dirt and germs.
One of chlorine's most important jobs is keeping us healthy by wiping out harmful bacteria and viruses. It's a superhero of disinfection. When added to water, chlorine transforms into a powerful germ fighter called hypochlorous acid. This acid attacks the cell walls of bacteria and viruses, destroying them before they can make us sick. That's why we use chlorine to treat our drinking water and keep our swimming pools clean. It's also a key ingredient in many household cleaners and disinfectants. Thanks to chlorine, we can wash our hands, clean our kitchens, and swim in pools without worrying about getting sick.
Besides its germ-fighting superpowers, chlorine is a busy bee in many other industries. It's a key ingredient in making paper, plastics, textiles, and even some medicines. Chlorine helps bleach paper, making it white and bright. It's also used to make polyvinyl chloride, or PVC, a versatile plastic used in everything from pipes to flooring. In the textile industry, chlorine is used to bleach fabrics and make them color-fast. And believe it or not, chlorine is even used to make some life-saving medicines, including antibiotics and anesthetics. Talk about a versatile element.
Section 5. Chlorine's not-so-friendly side. While chlorine is undeniably useful, it's important to remember that it can also be dangerous if not handled properly. Remember, it's a powerful oxidizing agent, which means it can react violently with other substances. High concentrations of chlorine gas can be extremely harmful, causing respiratory problems and even death. That's why it's crucial to handle chlorine with care and always follow safety instructions. Even in small amounts, chlorine can irritate the skin, eyes, and respiratory system. So always use chlorine in well-ventilated areas and wear protective gear like gloves and goggles when handling it.
Section 6. Chlorine's wartime role. A dark chapter. Unfortunately, chlorine's powerful properties have been exploited for destructive purposes in the past. During World War I, chlorine gas was used as a chemical weapon, causing widespread suffering and death. The first large-scale chlorine gas attack occurred in 1915, when German forces released tons of the gas on unsuspecting Allied soldiers. The effects were devastating, with thousands of soldiers succumbing to the poisonous gas. This tragic event highlighted the dangers of chlorine and the importance of international agreements to prevent the use of chemical weapons. Today, the use of chlorine gas as a weapon is strictly prohibited under international law.
Section 7. Handling chlorine safety first. Because of chlorine's powerful nature, we need to be extra careful when we're around it. Whether you're at the pool or using chlorine bleach at home, always remember these safety tips. First, never mix chlorine with other cleaning products. This can create dangerous and potentially deadly fumes. Always store chlorine in a cool, dry place, away from direct sunlight and heat, and always keep chlorine out of reach of children and pets. If you accidentally spill chlorine, don't panic. Ventilate the area immediately by opening windows and doors. Then carefully clean up the spill using appropriate protective gear and dispose of it according to local regulations.
Section 8. Chlorine in the lab, a chemist's companion. Chlorine is an essential tool for chemists, helping them create new and innovative products. Its versatility and reactivity make it a cornerstone in various chemical processes. In the lab, chlorine is used to synthesize a wide range of compounds, from pharmaceuticals to pesticides. Its ability to form strong bonds with other elements makes it invaluable in creating complex molecules. One of the most common uses of chlorine in the lab is as a reagent in organic synthesis. It plays a crucial role in the formation of carbon-chlorine bonds, which are fundamental in organic chemistry. Chlorine can be used to introduce chlorine atoms into organic molecules, which can then be used to create new compounds with desired properties. These properties can include increased stability, reactivity, or even specific biological activity. Chlorine is also used in analytical chemistry to determine the amount of chlorine present in a sample. This is crucial for ensuring the accuracy and reliability of chemical analyses. This information can be used to monitor water quality, test for the presence of pollutants, and ensure the safety of food and other products. By measuring chlorine levels, chemists can help protect public health and maintain environmental standards.
Section 9. Chlorine compounds, from salt to plastic. Chlorine is a social butterfly in the world of chemistry, forming compounds with many other elements to create a diverse range of materials. This element is essential in the production of numerous everyday products that we often take for granted. We've already met sodium chloride, better known as table salt, which is a staple in kitchens around the world. But chlorine's partnerships go far beyond the dinner table. It plays a crucial role in various industrial processes and products. One of the most versatile chlorine compounds is polyvinyl chloride, or PVC, a synthetic plastic polymer. PVC is a durable and inexpensive plastic used in countless applications from construction to healthcare. PVC pipes carry water to our homes, ensuring a reliable supply of clean water. Meanwhile, PVC flooring provides a durable and easy-to-clean surface, making it a popular choice for both residential and commercial spaces. Chlorine is also used to make chlorofluorocarbons, or CFCs, which were once widely used as refrigerants and propellants in aerosol cans. These compounds were revolutionary in their time, providing efficient cooling and convenient spray mechanisms. However, CFCs were found to damage the ozone layer, leading to significant environmental concerns and global regulatory actions. As a result, they have been largely phased out in favor of more environmentally friendly alternatives, which help protect our planet while still meeting our needs.
Section 10. Chlorine and the environment, a balancing act. Like any powerful element, chlorine can have both positive and negative impacts on the environment. Its dual nature makes it a subject of both praise and concern. On the one hand, chlorine plays a crucial role in sanitation and disinfection, keeping our water safe and preventing the spread of diseases. It is used in water treatment plants to kill harmful bacteria and viruses, ensuring that the water we drink is clean and safe. Chlorine is also essential in maintaining the hygiene of swimming pools, making them safe for recreational use. On the other hand, the production and use of chlorine can release harmful byproducts into the environment. These byproducts can contaminate water sources and harm aquatic life, leading to long-term ecological damage. For example, the production of chlorine gas often results in the release of mercury, a toxic heavy metal. Mercury can accumulate in the food chain, posing serious health risks to both wildlife and humans. To minimize chlorine's environmental impact, scientists and engineers are constantly working to develop new, more sustainable methods for producing and using chlorine. This includes researching alternative production techniques that reduce or eliminate the release of harmful byproducts. This includes finding ways to reduce mercury emissions from chlorine production. Advanced emission control technologies are being implemented to capture and neutralize harmful substances before they can be released into the environment. Additionally, scientists are developing alternative disinfection methods that minimize the use of chlorine. These methods, such as UV treatment and advanced filtration systems, offer effective sanitation without the environmental drawbacks associated with chlorine.
Section 11. The future of chlorine. New discoveries await. As we continue to explore the world of chemistry, we can expect to uncover even more fascinating uses for chlorine. Scientists are currently investigating chlorine's potential in a variety of fields, from medicine to energy production. For example, researchers are exploring the use of chlorine-containing compounds in new drugs to fight cancer and other diseases. Others are studying chlorine's role in photosynthesis, hoping to unlock the secrets of clean energy production. The future of chlorine is full of possibilities, and who knows what amazing discoveries await us. One thing's for sure: chlorine will continue to play a vital role in our lives, from keeping our water clean to advancing the frontiers of science.